Yeah, yesterday evening, for a brief moment, it was possible to see northern lights here, just above the house, really faint. And I tried to take a picture. That's maybe the best of it. It's not that sharp. But anyway, I was able to capture it. I tried to make a video also because they are moving, but it wasn't possible. It was too faint. This is now really strongly increased. This picture is the same, increased. Looks really ugly. And the interesting thing is that even though that we had quite some magnetic activity already this year, there should have been many times Aurora Borealis also visible here, but they weren't. And one thing is, quite often it was cloudy. Okay? May seem or sound as just a basic coincidence that there just happens to be clouds while geomagnetic activity. But somehow, yesterday, I noticed those, and it didn't take too many minutes, and we got a cloud cover immediately. And I want to show something to you relating to clouds and Aurora Borealis, which is the Kursk magnetic anomaly. It is a territory rich in iron ores located within the Kursk Belgorod and Voronezh Oblast in Russia, constitutes a significant part of the central Chernozem region. The Kursk magnetic anomaly is recognized as the largest magnetic anomaly on Earth. And it's this one. And the thing is, there is more to the whole structure of that in a way, because we have also a surface conductive anomaly, which is in a way shaped like that, and somehow it is connected to the whole Kursk magnetic anomaly. I'm not going to show you now the picture of this surface conductive anomaly because it got taken down from the internet a few months ago. And yeah, I tried to take contact with one of those who was making that map, but never ever anyone responded. And after a while, they just took the whole thing down from the internet, so I don't know what's going on. I tried to get more information about that. So now we have this magnetic anomaly here, which to some extent will go down into the ground, and to some extent will reach up into the sky, where we have our atmospheres and magnetospheres and those layers that we have. And now, one thing is, if we have geomagnetic activity which is coming from the outside, some of it will penetrate to the next layer, and some of it will go until to the surface, and some of it will go into the ground. So the thing is, what I was wondering, is it somehow possible that this Kursk magnetic anomaly works in a way repellent to Aurora Borealis, that they don't really form because of this magnetic anomaly. And furthermore, it just doesn't make only that you can't see the Aurora Borealis because somehow they dissipate or they cannot form. And in the same way, the charge differential between the atmosphere and the ground gets so strong that it creates fog or even clouds so that you cannot see it anymore. You cannot see the sky anymore. Yesterday, the ground, the fog or the clouds, which really quickly formed, they formed from the ground up. There was first fog on the ground, and we had about, 15 or 20 degrees minus. Almost no wind. But all of a sudden, there was this kind of ground fog, which just grew and grew, and then it rose up and it formed clouds. So you couldn't see the sky anymore. So we had geomagnetic activity. I saw for a brief moment Aurora Borealis. And after that, fog from the ground rose up into the sky and blocked out the whole sky. So is it possible that the surface conductive anomaly, which will come to greater knowledge probably in the next few days or something, I don't know, and the Kursk magnetic anomaly, do they affect Aurora Borealis here in the region and also the weather? Does it somehow amplify whatever weather patterns we have here if we have geomagnetic activity? Is there this kind of funnel which is going into the ground, and then because we have geomagnetic activity, it builds this kind of stuff here, and then you cannot see any northern lights, or because they just aren't there. But at the same time, the charge gets so intense that it starts to form water vapor. It gets somehow amplified up. This is just somehow a phenomena I yesterday noticed, because really, really rarely we have northern lights here. And we had one thunderstorm this year, or two, I don't know. I love thunderstorms, but we just don't get them here. And I think the thunderstorms are more related to this surface conductive anomaly, but which is also related to the Kursk magnetic anomaly. But the Kursk magnetic anomaly is easier to talk about because I can show you in Wikipedia and all this kind of. The other thing you don't find anywhere else. I have screenshots of it, but they took it down from the internet. You cannot watch or read or anything in there anymore, which sucks. But let's see. This is just somehow my observation about northern lights, fog, thunderstorms, Kursk magnetic anomalies, surface conductive anomalies, electromagnetics, and all these kind of things. Of course, that's a 10-minute video. There would be so much more about the whole thing to say and blah blah blah, but I leave it here. Just wanted to share you that yesterday we had some northern lights for a brief moment. Thanks. Bye.